Hey, this is Ray with CircuitSalad.com, and I'm going to do a quick demo of my half-bridge solid-state Tesla coil design. So there is all kinds of detailed information on my blog about this design, including waveforms and schematics and detailed descriptions of what I've done. It uses a current transformer to provide the feedback for self-excitation, but I've made some modifications to a traditional design to optimize the switching in the MOSFETs such that they run at very high efficiency and need very little heat sinking and cooling. And in fact, the MOSFETs I have in it currently are unremarkable, not particularly good quality MOSFETs, and they're not the ones I recommend for the circuit, but I just wanted to see if they work, and they seem to work fine. They don't get hot either. When you adjust this phasing for optimal switching, your streamer length increases and the efficiency goes up, which is really great. So again, there's all kinds of detailed information about this design on my blog, CircuitSalad.com. And so let's give this coil a demo. It can make 8-inch streamers with this primary, which isn't coupled ideally. I'm going to improve this and probably get closer to 12 inches when it's done, but I'll go ahead and demo it now. And so let's turn on my interrupter. So there we go, there's at 2 hertz. Let's turn out the light. Yeah. So if I get the camera phone too close, it starts spazzing out. So I'm going to try and adjust this here. Here's 10 hertz, 20, 30, and the duty cycle is about 10%. So let's up that considerably. Close to 50. So you can see I get a healthy spark off this thing. All right, so now let's see if these FETs are even warm. I can just barely perceive a little bit of warmth on the FETs. They're running cool, barely warm to the touch. And you can run this in continuous mode, and it takes a long time for them to get warm. In fact, these electrolytics get hot and the coils get hot before the FETs really warm up that much. Again, these FETs aren't even the ones I recommend. The ones that work best, the IRFP 4229, have a very low on resistance and have very little IR heating. And so you could drive very, very large coils and get very large streamers if you use those FETs. Those are in a TO 247 case. Anyway, check out all the details on my blog, CircuitSalad.com. The modifications you have to make to a standard half bridge to make these improvements. They're very minimal modifications, and they make a huge improvement and reduce the heating and the stresses on the MOSFETs considerably. Okay, thanks for watching.